Right now, as you're watching this, there's a planet the size of Jupiter hurtling through interstellar space at 200,000 miles per hour. It has no sun, no solar system, no home. It's been drifting alone in the frozen dark for 10 million years. And it's heading in our general direction. Not directly at us, probably. The margin of error is only about 500 billion miles, which in space terms is like saying, I'm pretty sure that bullet won't hit you. It'll miss by at least an inch. This isn't science fiction. We've detected over 200 of these things. Rogue planets, orphan worlds, planets that got ejected from their solar systems and now wander the galaxy like cosmic homeless. Except instead of asking for spare change, they destroy entire solar systems just by passing through. Conservative estimates suggest there are billions of these things in our galaxy, possibly more rogue planets than stars. For every point of light you see in the night sky, there could be 10 invisible worlds wandering in the darkness between them. Sweet dreams. The universe isn't just mostly dark matter and dark energy, it's also full of dark planets that could gravitationally pimp-slap our entire solar system into chaos without warning. Because the universe wasn't terrifying enough already. Here's the fun part. We can't see them coming. They don't emit light, they don't reflect much. They're essentially invisible until they're close enough to mess with our orbits. By then, it's too late. Imagine a bowling ball the size of Jupiter, painted black, rolling through a dark room toward your solar system. You won't see it until it hits something. And that something might be Earth's orbit. The last time we think one passed through our solar system? About 70,000 years ago. A brown dwarf and its companion passed through the Oort Cloud. Our ancestors were too busy inventing language to notice their night sky was being gravitationally molested. The next time? Could be tomorrow. Could be in a million years. We literally have no idea. But don't worry, the chances of a rogue planet hitting Earth directly are basically zero. It would just destabilize our orbit, sending us either spiraling into the sun or flying off into space to become a rogue planet ourselves. Much better. Welcome to the cosmic horror show of homeless worlds. Planets that lost the custody battle with gravity and now wander the universe looking for new solar systems to traumatize. How do you find something that doesn't shine in a universe that's mostly darkness when you don't know where to look? It's like trying to find a specific black cat in a coal mine at midnight while wearing sunglasses. Underwater. The story starts in 1998, not with a discovery, but with a "what the hell is that?" Astronomers are studying Sigma Orionis, a star cluster about 1,150 light-years away. They're looking for brown dwarfs, failed stars that weren't quite massive enough to start fusion. Cosmic participation trophies. Spanish astronomer Rafael Rebolo and his team find something weird. Objects too small to be brown dwarfs, but too big to be planets. And they're not orbiting anything. The designation S Ori 52. Catchy name, right? Mass? About 5 times Jupiter. Temperature? 1700 Kelvin. Hot for a planet, freezing for a star. Status? Completely alone in space. The astronomy community's reaction? That's impossible. Planets orbit stars. It's literally in the definition. The universe? Hold my beer. The naming disaster. What do you call a planet that isn't orbiting a star? Initial suggestions: orphan planets, too sad. Nomad planets, too romantic. Rogue planets, sounds cool, stuck. Free-floating planets, technically accurate, boring. Planemos, planetary mass objects, never caught on. Dark planets, also ominous, also accurate. Scientists spent more time arguing about what to call them than actually studying them, because that's what you do when you discover something that could fundamentally alter our understanding of planetary formation. You have a terminology debate. The floodgates open. Once astronomers knew what to look for, they started finding them everywhere. 2000, 18 candidates in Orion. 2003, 50 plus in various star-forming regions. 2006, over 100 identified. 2011, statistical analysis suggests billions in our galaxy. 2023, over 200 confirmed, thousands of candidates. How to find the invisible. Method 1. Direct imaging. Young rogue planets are still warm from formation. They glow faintly in infrared, like finding a recently used match in a dark room. Success rate only works for young ones, under 10 million years. Method 2. Gravitational microlensing. When a rogue planet passes between us and a distant star, its gravity bends the star's light. The star briefly brightens and dims, like an invisible magnifying glass passing by. Problem? Happens once, never repeats. 2011, the Ogle Survey. Optical gravitational lensing experiment, yes, that's the real name, detects something incredible. 10 Jupiter mass objects causing microlensing events, but the events are too short. These things aren't orbiting stars. They're flying solo through space. Ogle. They name their planet hunting survey Ogle, like they're creeping on the universe. Hey baby, nice gravitational lensing event you got there. The first confirmed rogue. 2013 MOA-2011-BLG-262. Rolls right off the tongue. Mass, 4 times Jupiter. Distance, 22,000 light years away. Speed, 45 kilometers per second relative to nearby stars. Companion, possibly has a moon, a homeless planet with a pet. This one wasn't a maybe. This was definitive proof. A planet with no star, just vibing in interstellar space. The Teenage Rogue. 2013 PSO J318.5-22. Astronomers are terrible at names. Age? 12 million years. A baby. Mass? 6 times Jupiter. Temperature? 1100 Kelvin. Still warm. Distance? 80 light years. Practically next door. Special feature, we can directly image it. This one we can actually see. It glows in infrared like a cosmic ember, a planet that remembers being warm, slowly freezing to death in the dark. The closest rogue. 2014 WISE JO 85511.83-071444.2.5. Seriously with these names. Distance? 7.2 light years. Mass? 3 to 10 times Jupiter. Temperature? 225 to 260 degrees Kelvin. That's warmer than Antarctica in winter. It's literally closer to us than 99.9% of all stars, and we just found it in 2014. It's been there all the time, just chilling in our cosmic backyard. Like finding out you've had a neighbor living in your hedge for 20 years. The terrifying math. Based on microlensing surveys, astronomers calculate minimum 2 rogue planets for every star in the galaxy. Likely 5 to 10 rogues per star. Maximum up to 100,000 rogue planets per star. Our galaxy has 400 billion stars. That means potentially 40 trillion rogue planets. The Milky Way isn't a galaxy. It's a cosmic homeless shelter for planets. And we're living in the nice neighborhood, completely oblivious to the trillions of gravitational hobos wandering around.
How does a planet become homeless? It's not like they're making bad life choices or refusing to get a job. These are victims of gravitational violence. Birth in chaos. Every solar system starts as a disk of gas and dust around a baby star. Planets form from clumps in this disk. It's like a cosmic kindergarten where everyone's fighting over toys, and sometimes kids get expelled. In young solar systems, planets don't stay in neat, stable orbits. They migrate, they fight. It's gravitational WWE. Jupiter-sized planets are the bullies. They migrate inward, throwing smaller planets around like cosmic dodgeballs. Sometimes those smaller planets get thrown right out of the solar system. Method 1. Gravitational slingshot. When two large planets pass close to each other, their gravity plays tug-of-war. One gains energy, one loses. Loser might get ejected at 50+ kilometers per second. Winner gets a slightly better orbit. Solar system loses a child. It's like cosmic musical chairs, except when the music stops, someone gets launched into the infinite void to freeze alone in darkness forever. Fun game. Method 2. Stellar abuse. Over 50% of solar systems have 2 or more stars. Imagine growing up with 2 suns that hate each other. Binary star orbits can be unstable. When they wobble, planets get thrown around, sometimes right out of the system. It's like having divorced parents who are both the size of the sun and settle custody disputes with gravity. Method 3. The drive-by shooting. Space isn't empty. Stars pass by each other. Not often, but often enough. When a star passes within a light year of another solar system, outer planets get gravitationally mugged. Orbits destabilize, some planets get stolen, others get ejected. Our sun has probably had 10 to 20 close encounters in its lifetime. We might have lost planets, we might have stolen some. It's cosmic grand theft auto. Method 4. Sibling rivalry. The Nice model, named after Nice, France, not because it's pleasant, suggests our early solar system had more planets. Computer simulations show we might have started with 5 to 6 gas giants. Jupiter and Saturn entered a resonance. This destabilized everything. Uranus and Neptune got thrown outward. A 5th giant planet got ejected entirely. We might have a homeless sibling out there. A whole planet that used to be part of our family, now wandering the galaxy, wondering why Jupiter was always the favorite. Method 5. Born homeless. Plot twist. Some rogue planets might never have had homes. In stellar nurseries, nebulae, gravitational collapse can create objects too small to be stars, but big enough to be planets. Planet-sized objects that form like stars, but fail at everything. These are the trust fund babies of rogue planets, born independent, but completely unprepared for reality. The rogue demographics. Most common rogues, Earth to Neptune-sized. Easier to eject, less massive, more numerous in solar systems, harder to detect, smaller. Most common, Jupiter-sized and larger. Harder to eject, need more energy, easier to detect, bigger, warmer, more likely to have moons. The moon situation. When a planet gets ejected, it can take its moons with it. Imagine Europa or Enceladus, moons with subsurface oceans, orbiting a rogue planet. These moons could maintain liquid oceans through tidal heating, if there are multiple moons, radioactive decay, or residual heat from formation. So somewhere out there might be a rogue planet with a moon that has a warm ocean full of life drifting through space like a cosmic terrarium that nobody ordered. What makes a rogue? Temperature. Young rogues, 1,000 Kelvin, still glowing. Middle-aged, 100 to 500 Kelvin, infrared only. Ancient, 3 to 50 Kelvin, basically invisible. Atmosphere. Might retain thick hydrogen atmosphere, acts like a blanket, could maintain quote-unquote warm temperatures. Surface might be minus 200 degrees Celsius, but that's warm for space. Composition. Rocky rogues, frozen solid, dead worlds. Gas giants might have warm cores. Ice giants, possibly liquid layers. The velocity problem. Ejection velocity determines fate. Less than 10 kilometers per second might stick around outer solar system. 10 to 40 kilometers per second escapes but stays in the galaxy. 40 to 60 kilometers per second, galactic escape velocity. 60 kilometers per second, intergalactic journey. Most rogues, 20 to 30 kilometers per second relative to nearby stars. Fast enough to be homeless, not fast enough to leave the galaxy. They're stuck in the galactic suburbs, too poor to move to a better neighborhood, too proud to move back in with their parent star.
Not all homeless planets are created equal. Like regular homeless, they each have their own tragic backstory and terrifying potential. the taxonomy of cosmic orphans. Type 1, the recent ejections, the fresh homeless. Type 2, the ancient wanderers, the career homeless. Type 3, the born free, never had a home. Type 4, the captured, adopted then abandoned. Type 5, the dying stars, technically not planets, but whatever. Type 1, the fresh homeless. Age, less than 100 million years since ejection. Temperature, still warm from their sun days. Detectability, relatively easy, they glow. Emotional state, if planets had feelings, confused and angry. Example, PSO J318.5-22. Ejected maybe 10 million years ago, still glowing at 1100K, probably wondering what it did wrong. Has aurora despite no sun, showing off. These are the easiest to find because they're still warm, like finding a recently divorced person at a bar. They stand out because they're radiating misery and heat. Type 2, the ancient wanderers. Age, billions of years in the dark. Temperature, 3 to 10 Kelvin, barely above absolute zero. Detectability, nearly impossible. Status, frozen solid, definitely dead. These have been homeless longer than Earth has existed. They've forgotten what warmth feels like. Their atmospheres have frozen and fallen as snow. They're cosmic ice cubes with planet-sized daddy issues. Imagine being so cold that your atmosphere becomes snow. That's like being so broke your money becomes debt. These planets have achieved maximum thermodynamic depression. Type 3, the born free. Never orbited a star. Formed directly from nebula collapse. Mass, 1 to 13 Jupiter masses. Any bigger and they'd be brown dwarfs. Attitude, I don't need no star. These formed like stars but failed the mass requirement. They're the community college dropouts of celestial objects. Too small to shine, too big to be normal planets. Example, WISE 0855-0714. Formed alone in space. Has water clouds, somehow. Temperature similar to North Pole, living its best life without supervision. Type 4, the complicated situations. Double planets ejected together. Rogue planets with moons. Binary rogues. 2 planets orbiting each other in the dark. MOA 2011 BLG 262. Rogue planet with an Earth-sized moon. Or tiny rogue star with Neptune-sized planet. We're not sure. They're codependent either way. Even in the infinite loneliness of space, some planets manage to maintain toxic relationships. They'd rather orbit each other in frozen darkness than be alone. It's cosmic Stockholm syndrome. Type 5, the questionable rogues. Brown dwarfs, 13 to 80 Jupiter masses. Too big to be planets, too small to be stars. Identity crisis manifested as celestial object. Sub-brown dwarfs, right on the border. Could be massive planets. Could be failed stars. Nobody knows. They don't know either. The theoretical nightmares. Rogue ocean worlds. Super Earths with thick hydrogen atmospheres. Greenhouse effect could maintain liquid water. Surface temperature, possibly above freezing. Life potential, disturbingly possible. Imagine an entire planet of dark oceans, no sun, possibly full of blind fish just drifting through space. It's like finding out Atlantis is real, but it's homeless and might crash into you. Rogue Earth-likes. Rocky planets with radioactive cores. Enough heat for subsurface liquid water. Thick ice shell on surface. Underground biosphere possible. If Earth got ejected today, surface would freeze in weeks. Oceans would freeze in 1,000 years. But deep ocean vents might stay active for billions of years. Life could survive underground. The speed demons. Hypervelocity rogues ejected by black holes or supernovae. Speed, up to 1,200 kilometers per second, 0.4% speed of light. Destination, another galaxy. Journey time, only 10 million years to Andromeda. Frequent flyer miles, infinite. These aren't just homeless, they're galactic refugees fleeing to another cosmic country. The adopted rogues. Sometimes rogues get captured by a star. Needs perfect angle and speed. extremely rare, usually temporary. Orbits are highly elliptical and unstable. It's like cosmic foster care. The planet gets a new home, but everyone knows it's temporary, and nobody's really comfortable with the situation. The wealthy homeless. Some ejected planets might be incredibly resource-rich, formed close to their star where heavy elements concentrate, got ejected with all their metals, diamond planets wandering in darkness, platinum cores just floating around. Somewhere out there is a planet made of precious metals worth quadrillions of dollars, and it's homeless. It's like finding out there's a solid gold shopping cart in the cosmic alley.
Finding rogue planets is like playing the universe's worst game of hide and seek. They're hiding in perfect darkness, they don't make noise, and the playing field is literally infinite. Space between stars, 99.999999999% empty. Rogue planets, 0.00000000001% of that. Our detection capability? Pathetic. Luck required? Astronomical, literally. The tools of futility. Method 1, direct imaging. Requirements. Planet must be young, still warm. Must be relatively close, less than 100 light years. Must be massive, Jupiter-sized or bigger. Must be lucky. Success rate? Found maybe 20 this way. Time to search entire galaxy? 47 billion years. Sun's remaining lifetime? 5 billion years. Conclusion? We're not finishing this search. Current infrared telescopes can see young rogues because they glow like dying embers. But young means less than 100 million years old. Most rogues are billions of years old and colder than my ex's heart. We're basically only finding the rogue planets that are still warm from their recent breakup with their star. The ones that have moved on and achieved thermal equilibrium with the void? Invisible. Method 2, gravitational microlensing. How it works? Rogue passes between us and distant star. Gravity bends light. Star appears to brighten briefly. We do math to figure out what happened. Problems? Happens once, never repeats. Lasts days to weeks. Need to be watching at exact right time. Can't follow up. It's like trying to study cars by watching their shadows pass your window once at night while you're asleep. The Future Nancy Grace Roman Space Telescope. Launches 2026, hopefully. Mission Microlensing Survey. Expected to find 250 plus rogue planets. Cost $3.9 billion. Chance of answering our questions? Minimal. We're spending $3.9 billion to maybe find 250 out of potentially 40 trillion rogues? That's like spending your life savings to count 250 grains of sand on all Earth's beaches, but in space, where the beaches are infinite. The ones that got away. For every rogue we detect, we miss thousands. Too cold to see, too small to detect, moving too fast, in the wrong direction, behind something else. 2019, mysterious gravitational anomaly detected. Could be rogue planet passing through outer solar system. Also could be measurement error. We'll never know. It's gone forever. Method 3, stellar wobbles. Even after ejection, stars remember their lost planets. The star wobbles slightly from the gravitational ghost. We can detect this wobble, but can't find the planet causing it. It's like knowing someone got divorced by how they act at parties, but never meeting their ex. Proposed insane solutions. Gravitational wave detection. Rogue planets technically emit gravitational waves. Frequency? Too low for current detectors. Solution? Build detector the size of the solar system. Cost? More than Earth's GDP. Likelihood? No. Occultation networks. Put telescopes everywhere. Watch every star constantly. See when rogues block them. Requirements? Infinite telescopes. Status? Not happening. Interstellar probes. Send probes to look for rogues. Speed? 5% light speed. Optimistic.
Time to search local area, 10,000 years. Chance of success, essentially 0. Our best plan is to launch probes that will report back in 10,000 years. By then, humanity will either be extinct or evolved into energy beings who don't care about rogue planets. Solid plan. What we know from not seeing them. The fact that we don't see more rogues tells us things. They're colder than expected, less recent ejections. They're smaller than expected, more Earth-sized. They're faster than expected, passing through quickly. Or they're way more than we thought and we're just blind. We're only finding the easy ones. Young rogues, glowing, easy to spot. Massive rogues, big gravitational effect. Slow rogues, more time to detect. Close rogues, obviously easier. What we're missing? Old, cold rogues, most of them. Small rogues, most of them. Fast rogues, the dangerous ones. Distant rogues, basically all of them. It's like studying elephants by only looking at baby elephants in your backyard. You're missing 99.9% of the elephants. The numbers game. Confirmed rogues, 200. Probable rogues, 1,000. Possible rogues, 10,000. Actual rogues in the galaxy, 40 billion plus. Detection rate, 0.000000000005%. We've detected 0.0000000005% of rogue planets. That's like claiming you've explored Earth after looking at 1 grain of sand on all Earth's beaches, while blindfolded. From space, where the beaches are infinite.
Let's talk about what everyone's really wondering. Can a rogue planet kill us? The short answer is yes. The long answer is yes, but in ways more creative than you're imagining. Scenario 1, the direct hit. Probability? Basically 0. But let's imagine it anyway, because anxiety is fun. A rogue planet aims directly at Earth. Detection time? Maybe 10 to 20 years out if we're lucky. Options? Literally none. Impact speed? 40 plus kilometers per second. Result? Earth becomes an asteroid belt. The good news? We'd have decades to contemplate our doom. The bad news? There's absolutely nothing we could do except argue about it on Twitter until the end. Scenario 2. The gravitational bully. Probability? Extremely low, but not 0. This is the actually scary one. Rogue planet passes through solar system, doesn't hit anything, just flies through. Its gravity disrupts all orbits. Everything gets slightly adjusted. Slightly means millions die. If Earth's orbit changes by just 1%, closer to Sun, temperature rises 5 degrees Celsius globally. Farther from the Sun, new ice age. More elliptical, extreme seasons. Tilted, poles melt, equator freezes. The dinosaurs had it easy with their quick asteroid. We'd get slow-cooked or freeze-dried over centuries. Scenario 3, the comet rain. Probability? Has happened before, will happen again. Rogue planet passes through Oort Cloud, disturbs trillions of comets, sends them toward inner solar system. Earth gets bombarded for millions of years. Not one extinction event, but thousands. It's like someone shaking a snow globe, except the snow is city-killing comets and we're inside the globe. Festive. It already happened. 70,000 years ago, Schultz star with a brown dwarf companion passed through our Oort Cloud. Distance? 0.8 light-years. Effects? Disturbed outer comets. Consequences? We're still seeing disturbed comet orbits. Human impact? None noticed. Too busy inventing agriculture. In 1.3 million years, those disturbed comets will reach inner solar system. Mark your calendars. The next close encounter, Gliese 710, coming right at us. Arrival, 1.29 million years. Closest approach, 0.05 light-years. Will pass through Oort Cloud, will definitely disturb comets. Comet shower, guaranteed. We have 1.29 million years to prepare. Current preparation, 0. We'll probably start thinking about it in 1.28 million years. Plot twist. We might have a rogue in our backyard. Planet 9, hypothetical. 5 to 10 Earth masses,
400 to 800 AU from Sun, highly elliptical orbit, might be captured rogue, might explain outer solar system weirdness. We might have adopted a rogue planet and don't even know it. It's like finding out you have a roommate who's been living in your attic for years. What if Mars gets ejected? If a rogue planet ejects Mars, Mars becomes rogue. Its orbit could cross Earth's first, potential Mars-Earth collision, or Mars just leaves. Bye. Either way, bad for colonization plans. Elon Musk is like, we're gonna colonize Mars. Rogue planet? What Mars? The encounter schedule. Based on stellar density and rogue estimates, a star passes within 1 light-year every 100,000 years. A rogue planet within 1 light-year every 10,000 years. A rogue planet through Oort Cloud every million years. A rogue planet through inner system every billion years. Direct hit every 100 billion years. The universe is 13.8 billion years old. How much warning would we get? Best case, massive warm rogue, detection 100 years out, confirmation 80 years out, panic 79 years out, acceptance 20 years out, impact or pass year 0. Worst case, small cold rogue, detection 6 months out, confirmation 3 months out, panic 3 months, Twitter memes 3 months, impact or pass? Surprise! The planetary launch scenario. If a massive rogue passes close, could gravity assist Earth? Increase our orbital velocity. We spiral outward, become rogue planet ourselves. Humanity gets free interstellar travel. Everyone freezes to death. We wanted to explore the stars. Careful what you wish for. We might explore them as a frozen corpse world. The swarm scenario. What if rogues travel in groups? Multiple planets ejected together, travel as a pack, gravitational chaos multiplied, solar system gets gangbanged by gravity, everything everywhere all at once, but bad. Could Earth survive as a rogue? If Earth got ejected today, week 1, photosynthesis stops. Month 1, surface temperature minus 50 degrees Celsius. Year 1, oceans freeze over. Year 1000, oceans freeze solid. Deep ocean vents might stay active for billions of years. Some life would survive. Deep ocean vent organisms, deep underground bacteria, anything that doesn't need sun, tardigrades, obviously. Probably not us. Humans wouldn't survive, but bacteria would thrive. Earth would become a giant frozen petri dish floating through space. Life finds a way, just not our life.
Here's a thought that'll keep you up at night. Rogue planets might harbor life. Not just microbial life, complex life, civilizations even, living in eternal darkness, never knowing stars exist. The heat problem, solved. Life needs energy, usually from stars, but rogues have other options. Radioactive decay. Uranium, thorium, potassium in the core provides heat for billions of years. Earth gets 47 terawatts from radioactive decay. Could maintain subsurface liquid water. Tidal heating. If Rogue has large moons, gravitational flexing generates heat, like Io around Jupiter, but lonelier. Could maintain oceans indefinitely. Primordial heat, leftover from formation. Large planets stay warm for billions of years. Jupiter still radiates more heat than it receives, even after 4.5 billion years. The underground ocean scenario. Imagine a super-Earth rogue planet. 5 times Earth's mass, thick hydrogen atmosphere, greenhouse effect, ice shell on the surface, liquid ocean beneath, heated by radioactive core, ocean temperature 0 to 30 degrees C, ocean depth 100 plus kilometers, chemistry rich in minerals, life probability disturbingly high. There could be entire civilizations of fish people living in pitch-black oceans on rogue planets, never knowing the universe exists above their ice ceiling. They probably have better healthcare than us. The atmosphere advantage. Without stellar wind stripping it away, rogue planets keep thick atmospheres, better heat retention, higher pressure at surface, could maintain liquid water, even with no external heat source. A rogue Earth with 10 times thicker hydrogen atmosphere?
Surface temperature above freezing, despite being in interstellar space. Greenhouse effect on steroids. Habitable, but dark as hell. What would rogue life look like? No photosynthesis possible, so chemosynthesis, using chemical energy instead of light. Like deep ocean vent life, sulfur and methane based. No need for sun. Probably smells terrible. Possible ecosystems. Hydrothermal vents, if oceans exist. Underground caverns, heated by radioactivity. Atmospheric layers, if thick enough. Ice-ocean interface. Nutrients concentrate there. Evolutionary adaptations. No light means no eyes. Useless. Enhanced other senses. Echolocation, possibly. Chemical communication. Bioluminescence for communication only. Imagine dolphins, but blind, in a dark ocean, on a frozen planet, drifting through space. And they're probably philosophizing about the meaning of existence without knowing stars exist. Deep. Rogue planets as life carriers. Theory, rogues could spread life between star systems. Life evolves in original system, planet gets ejected with life aboard, wanders for millions of years, life survives underground, underwater, planet gets captured by a new star. Life reemerges. Galactic pandemic achieved. Rogue planets might be the universe's version of that person who goes to work sick and infects everyone. Except instead of the flu, it's spreading life across the galaxy. Could intelligent life evolve? Requirements for intelligence. Energy source, check. Geothermal. Complex chemistry, check. Oceans. Time, check. Billions of years. Evolutionary pressure, check. Harsh environment. Ability to manipulate environment. Question mark, harder underwater. Possible, yes. Probable, who knows? Terrifying, absolutely. A civilization in eternal darkness. Imagine an intelligent species on a rogue planet. Never seen stars, don't know space exists, think their world is everything. Mythology based on heat and cold, technology based on geothermal energy. Their science. No astronomy, advanced geology, incredible acoustics, chemistry without combustion, nuclear physics from radioactivity. They'd develop faster than sound travel before discovering there's a up beyond their ice ceiling. Their space program would be drilling. Their NASA would be DASA, drilling and subterranean administration. First contact with rogue civilization? How would we even communicate? They don't know light exists. We don't know their sensory modes. They think the universe is 100 kilometers of ocean. We think intelligence needs stars. The conversation. Us. We come from the stars. Them. The what now? Us. The bright points of light in space. Them. Light? Space? Are you having a stroke? The ethical dilemma. If we find life on a rogue planet, do we leave it alone, Prime Directive style? Make contact? Traumatize them with reality? Try to rescue them? To where? Study them. Zoo ethics. Hey, your entire worldview is wrong. The universe is infinite. You're on a frozen ball of rock hurtling through nothing. And by the way, you're homeless. Want to be friends? Visiting a rogue world. The logistics. Finding it? Nearly impossible. Reaching it would take centuries. Landing. On what? Ice? Ocean? Surviving? In complete darkness. Returning. Good luck with that. It would be the most expensive, dangerous, and pointless mission ever conceived. So we'll probably do it. The ultimate isolation. Rogue planet life would be separated by light years from anything, unaware of the separation, alone but not knowing it. The universe's most isolated life, also possibly the most common. There could be trillions of living worlds in the dark between stars, each thinking they're the only life in existence. We thought we were alone in the universe. At least we can see the universe. Rogue planet life is alone in a darkness they think is everything. It's cosmic solitary confinement, but they don't know it's confinement.
The existence of rogue planets doesn't just add some homeless worlds to our cosmic census, it fundamentally breaks our understanding of basically everything. Planetary formation. Everything we knew was wrong. Old model, planets form and disks around stars stay there. New model, it's basically a cosmic food fight where planets get thrown everywhere. If there are 5 to 10 rogues for every star, most planets get ejected. Stable solar systems are the exception. Earth's stable orbit is cosmic lottery winning. We're the 1% of planets. We thought solar systems were like happy families with planets in stable orbits. Turns out they're more like dysfunctional families where most kids get kicked out and become homeless. The cosmos has daddy issues. The Fermi Paradox solution. Where is everybody? Maybe they're on rogue planets. If most planets are rogues, most life might be on rogues. They can't communicate, no technology. They don't know space exists, they're invisible to us. The universe is full of isolated life. The galaxy might be teeming with life, just all underground on frozen worlds drifting in darkness. The universe's biggest ghost town is actually fully occupied. Updating the Drake equation. The equation for estimating alien civilizations needs updating. Old variables, stars with planets. New variable, planets without stars. If rogues outnumber starbound planets 10 to 1, 10x more potentially habitable worlds, but 100x harder to develop technology, 1000x harder to communicate. Result, universe full of life we'll never meet. We've been looking for aliens around stars like looking for fish in trees. Meanwhile, the cosmic ocean is full of fish floating in the dark between the trees. Solar systems aren't permanent. Every solar system is temporary. Young systems, chaotic, ejecting planets. Middle age, stable, like ours for now. Old age, star dies, planets either consumed or ejected. End result? All planets become rogues eventually. Earth's future? Rogue or consumed by sun. Timeline? 5 billion years. Our choice? Neither. Our fate? Predetermined. Rogue planets are mixing the galaxy. Rogues don't stay in their birth neighborhoods. Ejected at high velocity, travel across the galaxy, mix different regions, spread materials, and maybe life. The galaxy's circulation system. It's like cosmic gentrification, planets from the galactic suburbs getting kicked out and wandering into other neighborhoods, changing the local dynamics. Could rogues be dark matter? Speculation, what if rogues contribute to dark matter? Requirements, need 5x more mass than normal matter. Rogues would need to outnumber stars 100,000 to 1. Most would need to be small and cold, basically invisible. Probably not all dark matter, but maybe some? Current opinion? Unlikely but not impossible. My opinion, the universe is weird enough that, sure, why not? We can't find 85% of the universe's mass. What if it's just homeless planets? That's stupid. Do you have a better idea? No. What this means for human expansion. If rogues are common, interstellar space isn't empty. Could use rogues as stepping stones, mine them for resources, uses generation ship rest stops. The galaxy has hidden gas stations. Instead of jumping star to star, we could hop between rogues. It's like discovering there are islands between continents. Dark, frozen, lifeless islands, but still. Could we capture a rogue? If a small rogue passes near our solar system, could theoretically capture it. Would need massive space infrastructure, could mine it for resources, could use as Mars alternative, could accidentally destabilize everything. Hey, let's capture that homeless planet. What if it disrupts Earth's orbit? Worth the risk for space real estate. Human decision-making at its finest. The existential crisis. Rogue planets mean most worlds are alone in darkness. Star systems are temporary. Planetary homelessness is normal. Earth's situation is abnormal. We're living in a cosmic gated community. We thought we were normal. We're not. We're the weird ones with our stable orbit and visible star. We're the cosmos' privileged kids who don't realize how good we have it. The ultimate fate. In the far future,
trillions of years, all stars die, all planets become rogues, universe becomes dark, only rogues remain. The universe's final state, homeless worlds in darkness. The universe doesn't end in fire or ice, it ends in rogue planets, drifting alone in the dark, possibly still harboring life that never knew light existed. The universe's final chapter, an infinite collection of frozen worlds with possible underground civilizations, all unaware of each other, thinking they're alone. It's not the heat death of the universe, it's the alone death of the universe.
So now you know. The universe is full of invisible, homeless planets that could gravitationally mug our solar system without warning. How do we live with this information? The next decade of discovery. 2026, Nancy Grace Roman telescope launches. We'll find 200+ rogues via microlensing, still missing 99.9999% of them. 2029, extremely large telescope operational, can directly image young rogues within 100 light years only. 2030s, LISA, gravitational wave detector, might detect massive rogues if they're doing something interesting, probably won't. 2040s, interstellar precursor missions, might stumble upon rogues accidentally while doing something else. Our detection strategy is basically, maybe we'll get lucky. It's like looking for invisible needles in an infinite haystack while